This is the last 4 problems from that Lewis Structures worksheet. First we had SF6. Now what I would do is say S is going to go in the middle, and the fluorines, 6 of them, we'll put them around the outside. Now here's my 4. Then if I still have 2 more, I'm going to put them in the corners like this. Now what happens is a fluorine atom, we know, has 7 valence electrons, so it needs 1 more electron in order to make a bond. So for the sulfur, then you have to use 1 of its valence electrons to make that little connection. So I can see that I'm going to need 1, 2, 3, 4, 5, 6 of my sulfur's valence electrons just to connect the fluorines. Now that leaves the other lone pairs on the fluorines. So you can see what happens here is that there's my picture, and that picture needs sulfur has 6 and each of the fluorines have 7. So 6 times 7 is 42 plus 6. You're going to take 48 electrons, and that's how many electrons I've drawn. So this is the picture that would go for SF6. Now how can sulfur make 6 bonds like this? Is it's using some of its d orbitals as well as the s and p's, so we call this the extended valence shell. For xenon with 4 fluorines, I'll do the same thing. So here's xenon, and I'll put my fluorines around the outside. Now again, xenon, we know that has 8 valence electrons, and normally it doesn't make bonds, but xenon is so large it actually is reasonable to get make bonds out of this. What will happen is 4 of its electrons are used to connect the fluorines. That still leaves 4 more, and so I'm going to write those as 2 lone pairs, and I just put them over here in the corners. So here's fluorine, 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 and fluorine, and that's the picture that goes for xenon hexafluoride. Now the shape of this, it's going to have 6 different things around the xenon, so it's going to be octahedral. What happens though is there's a lone pair on top, lone pair on the bottom, and these other 4 stick out, and we're going to have a square planar shape. PCl5, we know phosphorus has 5 valence electrons. It's going to take those 5 to connect on the 5 chlorines. So 1, 2, 3, 4, 5. So those are its valence electrons. And the chlorines, just like the fluorine, still has another place here to make a bond. And so it has 3 lone pairs left over. So this has 5 bonds coming out of it, and that would be S, the 3 P's, and 1 of the D's. That's this picture. The last one is SeF4. Well, Se is in the same family as oxygen, so it has 6 valence electrons. Okay, the fluorine's 7, and so 7 times 4 would be 28. So we have a total number of electrons here of 34. So we have selenium has 6 valence electrons. It requires 4 of those electrons to hold on the fluorines. That leaves 1 more pair of electrons for selenium, and then we fill in the lone pairs. So that would be the picture here for selenium tetrafluoride. 5 bonds from the selenium, and that would be trigonal bipyramidal. and that lone pair is going to end up being in the equatorial position. So there'll be a fluorine up here, there'll be a fluorine down here, 2 fluorines, and there's selenium here in the middle, and that would be the seesaw shape. That's it.